All right.
If you check on this battery, I have 1, 2, 3, 4, 5, 6 cells. 6 cells, no? Suppose that the voltage of each cell is 1.3. How much is 1.3 times 6? Calculator, quickly. 1.5, sorry.
Oh, okay. 5 times 6. 9.
It's 9 volts. Let me check how much is the voltage in each cell in this battery. Okay. Okay. I am going to check in DC the voltage, the total voltage in between the positive and the negative. How much is that?
It's 12.07.
12 point. Okay, and now the voltage in between the last cell and the last
1.7, 1.8, almost. 1.7 fluctuates. So 1.7.
1.7 in each cell.
That's 10.2.
Excuse me?
10.2.
10.2. Okay, look. And in between the last one and the second cell,
2.
2. Yeah? Can you open this one? If you go up, at the end you have 12. It's because each cell is connected in series with the other one and the other one and the other one and the other one. For example, in between the last terminal and this cell,
9.7.
9.7. And with this one,
12.6.
12. You see? It's going up, up, up. You add it. Oh, nice. Nice that connection, no? Each cell is connected in series with the other one, 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 and finally I have the 12 volts.
We increase the voltage.
Okay, the battery is a composition of cells, individual cells. Okay, what happens if one of the cells is damaged, is broken? The connection is serious. What happens if one of the middle cells here is broken?
There's an interruption in voltage.
The battery is broken because it's in series. No? For that reason, when the people test the battery, we are going to do that procedure right now. They verify cell by cell. Oh, look, this one is broken. For that reason, the battery is damaged. Can you fix it only that cell? No, my friend. I need disassembly the battery and replace the LEDs, the plates of LED. No, that's not possible. You need to repair the battery completely, remove all the lead, all the acid, and install new cells. Create a new battery. Okay? If one cell is damaged, bingo, finito. That's not good. Everybody follow me? That's clear? Okay. Okay. We are going to try to check something. In each cell, I have plates of lead. Depending on the thickness of the plates, the batteries store more energy or less energy. If the thickness of the plate is thicker, the batteries store a lot of energy and release the energy slowly. What type of battery is that battery? It stores a lot and release the energy slowly.
Deep cycle.
Deep cycle. Deep cycle, the second one. Deep cycle. But I have other battery with the plates, thinner plates. And stores energy but release the energy faster. What type of battery? Cranking batteries. Okay. That's why the deep cycle batteries are heavy in comparison with the cranking. The crankings are a little lighter in comparison with the other one. Because the other one, the plates are thicker. Good, no? Nice. Those are the main difference, no? In between deep cycle and cranking batteries. There are other type of batteries, dual purpose. The plates are in between both of them for small boats, dual purpose. When I have a small boat with only one outboard and a small console, the dual purpose is okay, no, Danny? It's common, no? It's common.
Yeah.
Cranking batteries, heavy cranking batteries like this one, is exclusive for inboard engines, diesel or gas, heavy engines, no? I need a lot of amps at the beginning.
Yeah, in the new motors today, you need to have good cranking amps because of the
Yeah.
computers and all that.
Okay. Doesn't matter.
Yeah,
So,
the minimum now on the new outboards about 650 full cranking amps. The minimum.
the minimum is a lot.
yeah.
Right now we are going to talk about that. What is the meaning of CCA and AC? Those measures. Right? Okay. Those are the different types. And the other difference in the batteries is the electrolyte. The most common batteries, this one and this ones, are lead acid. What is the meaning of that? I have electrolyte here, and I have plates of lead. No? This is lead acid. There are other ones identical to this, but internally, the liquid is not liquid, it's gel. Because they added additive, and it's not liquid, it's gel. This is good, because the gel, no spill. But the gel battery is a lead acid battery. And there are other ones exactly the same. 65% of acid, 65 of water, 35 of acid. But they added silica, powder of silica, and the silica absorbed the water with the acid. This is the AGM, absorbed glass material. But it's basically the same. It's acid with water plus silica to absorb the liquid, and right now the liquid is not liquid, it's not gel, it's powder, wet powder, and it's good electrolyte. In sailboats, in catamarans, they prefer, in boats in general, the people prefer AGM or gel because with the movement of the boat, you don't have spills of acid. That's okay? Those are the different types. And other good electrolyte is the lithium ion. Later we are going to talk about that. Ions of lithium. Lithium, you remember the periodic table? Lithium, cadmium, lead. What is the other one? Are good metals to storage energy. Lithium, cadmium, beryllium, and lead. They store us a lot of energy and release the energy slow. Lithium, cadmium, beryllium, and lead. Of course, the people prefer lead because it's cheaper. It's too cheap. What about lithium and beryllium? Cadmium, it's too expensive. It's too expensive. That's the difference in price in between this battery and this battery. This is the cheapest battery. The voltage fluctuate in between 1.70 and 2.12 in each cell. No? You remember we verified here. We're going to check again, Danny. We are going to check the voltage of one individual cell, the first cell. 2.6, yeah? All right. This is the maximum in each cell. All right. Look at this. When the battery is fully charged, the maximum voltage per cell should be around 2.12. And this is an indication that the battery is fully charged. Look at this. If I have in one cell, I check the voltage of the cell, and the voltage of the cell is 2.0. The battery is 60% charged. That's incredible. No? The people say, no, the voltage in each cell is 2, it's okay. No, my friend. The level of charge in the battery is 60%. Look at this. Some people say, my battery is perfect. Yes, it's perfect. Can you check? What is the voltage of the battery? It's 12.2, 12.1. Look at this. 12.2, 12.1. The battery is around 50% of the charge. And the people normally say, I have 12 volts. That's perfect. 12 volts, the battery is 50% charged. It's in the limit to be discharged. What should be the voltage in a normal battery fully charged? Around 12.7. 12.6, 12.7. Less of that, 12.5 is 90% charge. 12.0, 50% charge. No, my battery is a little discharged. It's 11.7. 11.7 is 30%. Your battery is practically that. Wow. No, it's a little discharge. No, my friend. 11.7 is practically finished. Okay. This is only using the voltmeter. And remember, the voltmeter is not a good indicator to check the battery. The battery should be verified with the load tester. Right now we are going to play with the load tester. Anybody?
Yes, sir.
Don't forget that table, because that table is nice. When you talk with your customer, no, my battery is perfect, it's 12 volts, 12.0. My friend, your battery is dead. No, okay. Let me put the load tester. Yeah. No? Yeah. Okay, look. Now we are going to think in a boat. In a pleasure boat, 65 feet. How many battery banks are in a typical pleasure yacht?
About there, five. Boat thruster,
Five, around
boat,
5, 4, 6
stern,
groups. One group, cranking. Other group,
house,
house. Other group,
stern, bow,
bow thrusters. Other group,
generator.
generators. Other group,
Electronics.
electronics. Those are the most common. No? Probably the people say, no, I have other group for the solar system. Okay. Yeah? But it's around 6 group of batteries. What is the secret when I have different group of batteries in my boat? The secret, the tip number 1.
All negatives should be
All the
bonded to
negatives,
negative
I have
one.
this group here connected in series or parallel. No problem. Blah, blah, blah. The output positive and the output negative. No? And I have other group here, output positive, output other here, other here, other here. 6 group of batteries. All the negatives should be connected together in a common negative bus bar. The negatives should be connected together. Doesn't matter if this group of battery is lead acid, the other group of batteries is gel, the other group of batteries is AGN, no problem. Doesn't matter if this group of batteries is 12 volts, this one is 24, this is 12, 24, 12, 24. All the negatives should be connected together. Anybody follow me? Why?
For the,
Why?
the signal for any electronic to
The
receive
signal.
and transmit.
Pay attention. We are going to do a simple example. Danny. I forget. Sorry, Danny. Can you bring one second? The battery bring that. Okay. All right. Look at this. Suppose that I am in the pilot hand or in the fly bridge. I am the captain. Anybody follow me? I am going to try to start the engines with the ignition switch on the pilot hand. Ready? Pay attention. The start motor of the engine, where is located? On the engine. And the motor of the start motor receives power from what group of batteries? The cranking battery is pretty close to the engine over there. Yes or no? The big red cable entered in the solenoid of the start motor. You remember that? Okay. Dr. Raul, no? Big positive enter over there. Okay. The signal to activate, the battery. Use for the. Look, the signal to activate that solenoid is coming from the ignition switch located over there in the pilot hand. Excuse me, the ignition switch over there, that ignition switch receives the signal from what group of batteries? Excuse me? House battery bank or electronics. One of those. And I send that signal to the solenoid, and the solenoid and activate the motor. Yes or not? Sure. Excuse me. If the negative of that group of batteries, house batteries, is not connected with this group, cranking button, that signal, can I send the signal? No, because the negatives are not connected and I don't close the loop. Wow, this is a typical complaint. Oh, my engine start, if I start the engine directly on the engine, But in the pilot hand, nothing. You enter with an alligator cable, connect the negative. Oh, you start! The negatives are not connected.
In most common electrical problems, it's usually due to a bad ground.
Yeah, yeah. Danny,
Especially with corrosion. ¿Qué
I want to
sacarla
put this
de
battery over there.
Oh, that's where you want.
Yeah,
Okay.
yeah, that
You
one.
got
Okay. I have a here. Look.
Adjustable.
All right. Good. The negatives, Angel, welcome. The negatives should be connected together and should be connected in a common negative bus bar. No? That common negative bus bar, the big one, normally is located in the engine room. However, I have other negative bus bars in other places. I have one negative bus bar in the console, other in the cabin, yeah, in different places. But all of those negative bus bars converge in the big main negative bus bar of the DC of the engine. In other words, the negatives in any part of the boat are the same. It's common. Doesn't matter if I am using this group of batteries or that group of batteries, the negatives are the same. I can close the loop in any part of the boat. Everybody follow me?
Yep. Nice.
It's clear, no? And don't forget, doesn't matter if this group of batteries is lead acid and the other one is AGM and the other one is lead. No problem. No problem. At the end of the day, doesn't matter the material of the battery, the group is 12 or 24 or 36. And the voltage is the same. Ready? Good? Okay. The situation now, we are going to play a little with this type of board. This is the board that we are going to do here. This is the laboratory that we are going to create. Each 3 people will be responsible for the design of one board. And we are going to connect the boat completely. This is a complete boat. Because we have the start motor, we have the alternator here, we have the fan, we have all the instruments, oil pressure, temperature sensor, tachometer. We are going to connect everything. This is the boat, navigation light. This is the boat, bilge pumps. Yeah, this is a.
Is that the ACR?
Yeah, the ACR and the battery charger. We have everything here. If you do that project, you are ready to do the wiring in a small boat DC.
And we're gonna sabotage them. You're gonna have to figure out what.
The final exam is with Danny and me.
I love sabotage.
Yeah. We cut the cable. Hey, my friend, try to start. Hey, no start. Where is the problem? Okay, one more minute. No, Mr. Lab, sorry. We are going to start with cranking battery. No, over there.
Oh, towards me.
Thanks. But cranking battery. And we are going to talk about those three information that you have in the label of the battery. In my opinion, the information that you need every day is the amps per hour and the CCA. Now we are going to talk about both of them. What is the meaning of amps per hour? What is the meaning of amps per hour?
The amount of amps per deciliter.
Correct. What is the capacity of the battery to storage energy? And what is the capacity of the battery to deliver that energy in amps per hour? How many amps per hour pass for that point in 1 second? Or 1 hour or 1 minute? It's flow. It's flow. Okay, for example, this battery is 100 amps per hour. But normally in the label of the battery, I don't know why, they don't mention the amps per hour. They say reserve capacity, 180. They don't mention amps per hour. But I say in the book that you can multiply the reserve capacity 0 times reserve capacity times 0.416 is equal amps per hour. That's okay? How much is 180 times 0.41, please?
73.8.
72?
70, yeah, 72. 70, well,
the
74.
capacity of that battery is 72 amps per hour.
Yeah.
That's okay? It's 70 amps per hour. That's the capacity of that battery. They put reserve capacity instead of amps per hour. You need the information about amps per hour. But it's simple. You multiply reserve capacity times 0.41 and T72. That's okay, right? 74. It's because your Mickey Mouse calculator.
No, I was trying to say 74, and you were like 72. I was like 74.
No. Hello Kitty calculator. All right. But is in the future, look, I memorize because 0.41 is complicated, I say 0.5. Okay, reserve capacity, half is amps per hour, approximately. What is half of 180? It's 75. Yeah, half. Forget 0.41, 0.5. Good? It's simple, no? Half of the reserve capacity is the amps per hour. Finish. Okay, this is, but it's okay. All right. This is the information that you need. Let me explain why, because in a couple of minutes we are going to play with that. Because in some cases you need collect 600 amps. You need a battery bank of 12 volts and 600 amps. And you have only batteries of that capacity. Pay attention. You need a battery bank of 12, 600 amps. How many batteries you need over there and how should be connected those batteries? You need 600 amps and 12 volts. In series? In series? In parallel, Dr. Garfield. Because in series you increase the voltage. Should be in parallel. How many batteries? How many batteries in parallel? 8 batteries, no? This is a parallel connection. This is a parallel connection, no? Suppose that you connect 8 of these. How much is the output voltage and the output amps? The output voltage should be 12 because it's in parallel, no? And if you have 8 batteries, how much is the total amps? Each battery is 75 amps. 75 amps, 75 amps, 75 amps, 75 amps. How much? If you multiply 75 times 8,
600.
600. Okay, perfect, perfect. I need 8 batteries. Finito. In parallel. Good?
Buy bigger batteries so you have less.
Or I can buy one battery like this.
Right to back.
This is 12 volts, 850 amps. With one.
Have fun carrying that.
But you need a man like me to move that battery.
He thought that was really funny.
Stronger. No. You need to be careful removing those stupid batteries, Danny. I am destroyed for those batteries. Oh, it's simple. Can you replace my batteries in my boat? Only 4 batteries. Where are the batteries? Over there. Oh, wow.
No, Mr. You have too many girlfriends. It ain't that.
Yeah, it's good. It's good. Okay. Good. Other number. No, a little bit. Other number that is critical is this. What is the meaning of CCA?
Cold cranking.
It's the amount of amps that the battery delivers for 20 seconds at 0 degrees Fahrenheit. Something like this, no? How many amps the battery delivers for 20 seconds at 0 degrees Fahrenheit? This is the CCA. The CCA is a vital information when you try to select the battery for cranking purposes. For example, in the course of diesel, you need to select the proper battery according with the star model. That star model requires a battery with a CCA 850 CCA, and should be no less than this. A little more is better, because this is the capacity of the battery to deliver the amount of amps in the morning when the temperature is too low. You understand?
Overview of parts.
That information is critical for the selection of cranking battery, the CCA, called cranking amps. Some batteries today, marine batteries, they have MCA, marine cranking amps. It's pretty close to CCA. That's okay? It's the amount of amps that the battery can deliver at a low temperature for 20 seconds.